Hello everyone, how are you today? I hope you're all doing well today. Okay, before we begin, let me introduce myself. My name is Nila Kaputriani, and you can call me Eka. Nah, okay, today we are going to learn about factor. Okay, are you ready? Let's get started. Okay. Now, in physics and mathematics, quantities are divided into two main categories. There are scalars and vectors. Okay? Understanding the difference between them is the foundation of vectors algebra. Okay, scalar. We have scalar. Now, scalar is a quantity that has magnitude size only. Now, for example, distance, speed, time, temperature, and energy, and so on. Okay. Okay. Vector. What is vector? Now, vector is a quantity that has both magnitude and direction in space. For example, displacement, velocity, acceleration, and force, and so on. Okay. Now, okay. Okay, now in mathematics, vector are fundamental objects that represent quantities with both magnitude and direction. Now, they are widely used in various uh, branches of mathematics, now physics, engineering, computer science, and other. So, look at this picture. Okay, now in the above figure, now the length of the line represents the magnitude, while the arrowhead indicate indicate the direction of the vector. Now, a vector can be thought of as a directed line segment denoted as AB, where A is initial point or we call starting point, and B is terminal point or we call end point. So look at this. So in vector, uh, we know that the magnitude. Now the magnitude is the size or length of the vector, usually denoted by this, the absolute value of v or the norm of v. Okay, and we have direction, the direction of the vector in space, usually represented by the arrowhead that indicates where the vector points. Okay. Now, representation of vector. Now, vectors are represented by taking an arrow above the quantity to indicate that it has both magnitude and direction. For example, the first vector is represented this f, for the row above f represent that it is a vector quantity. So vector can also be represented by taking their respective magnitude in x, y, and z direction. And then the x direction is shown using I hat. The y direction is shown using G hat, and the z direction is shown using K hat. Or usually we call IGK instead of I hat, G hat, K hat. Okay. And thus, a vector A can be written as this. A is equal to xy plus xi plus yg plus zk, where x is magnitude of the vector along the x-axis, y magnitude along the y-axis, and z magnitude along the z-axis. Okay. Okay, you can remember this. The point where the vector starts is called the tail of the vector, and the end point of the vector is called the head of the vector. We can also denote the vector as the coordinate point in 3 dimensions. Okay. Sorry, okay. Magnitude component of vector. Okay, for any vector, A, its x component is a sub x, and its value is a sub x is equal to a times cos theta, and y component is a sub y, and its value is a sub y is equal to a times sin theta, where theta is the angle formed by the vector with the positive x-axis. Also, the magnitude of the vector is calculated using the formula. The absolute value of a is equal to the square root of a sub x squared plus a sub y squared. So, next. Okay, angle between two vectors. Okay, if two vectors in 2D plane intersect each other, then the angle between them can easily be calculated using the dot product of the vector formula. We know that for two vectors, vector A and vector B, their dot product is given by this A dot B, vector A dot vector B is equal to the magnitude of vector A times the magnitude of vector B times cos theta, or we can, using this formula, cos theta is equal to vector A times vector B divided by the magnitude of vector A times the magnitude of vector B. Okay. Let's move on to types of vector. Okay, vector can be classified into different categories on the basis of their magnitude and direction. Okay, the first type is zero vector. Okay, a vector with zero magnitude and no direction written as 0, 0, 0 and satisfies vector a plus 0 is equal to vector a. Okay, next we have a unit vector. A vector with unit magnitude given as vector c is equal to vector c divided by the magnitude of vector c. And then, uh, okay, we also have a equal vector. Equal vector is vector with the same magnitude and direction regardless of their initial and terminal point. Then we have a negative vector, a vector with the same magnitude but opposite direction as the original vector, denoted as negative vector A. And then we also have co-initial vectors. A vector that originate from the same point are called co-initial vector. Then collinear vectors. Two vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitude and direction. And then parallel vector with the same direction and an angle of 0 between them, though magnitude may differ. And the last is orthogonal vector. Vector at right angle, 90 degree to each other with a dot product of 0. Next, let's move on to operation of vectors. Now, we can perform various operations on vector by taking a geometrical approach by taking a coordinate system approach. Now, various operations in vector are, first is addition vector. Okay. The addition of two vectors, vector A and vector B, is given by adding their corresponding component. Okay. If A is AI plus BG plus CK and B is PI plus QG and plus RK, we get the vector A plus vector B is equal to this. A plus P times E plus B plus Q times G and plus C plus R times K. Okay, the second type is subtraction of vector. Okay, the difference between two vectors is given by subtracting their corresponding component. Okay, this vector A minus vector B is equal to A minus P E A minus PI plus B minus Q G and plus C minus RK. Okay, next we have multiplication of vector by scalar. Okay, multiplying a vector A by a scalar K scales its magnitude. This K times vector A is equal to K times A sub x, the component of x in vector A, comma K times A sub y, and comma K times A sub z. So next we have dot product. Okay, the dot product of 2 is a scalar. So if A vector A dot vector B is equal to A dot Pi plus B dot Qg plus C dot Rk. Okay, the last we have a cross product. So the cross product of two vectors is a vector perpendicular to both. Okay, if A vector A is this and vector B is this, then we can get A cross B is equal to B times R minus C times Q I plus A AR minus CP G plus A AQ plus minus BP K. So let's move on to solve example on factors. Okay, let's say two factors are defined as factor B is equal to A minus C plus 2D, and factor A is 3E minus D plus 2C. So find B factor B plus A. So given factor B is this and factor E is this, factor A is this. So now let's calculate factor B plus factor A. So we get, okay, by adding the components, we get A minus C plus 2D plus 3 E minus C plus 2D plus 3E minus D plus 2C, and we get factor B plus factor A is equal to 4E plus C plus D. Okay, the second example, okay, find the magnitude of the factor A is equal to 2I minus 5G plus 4K. Okay, given factor A is this, and we know that the magnitude of factor A is the absolute value of A. Okay, and we use this formula. The magnitude of factor A is equal to the square root of A square plus B square plus C square. And we substitute this value to the formula. We get the magnitude of factor A is equal to the square root of 2 square plus negative 5 square plus 4 square, and we get the magnitude of vector A is equal to the square root of 45, and we get 3 times the square root of 5. Okay, that's all of my presentation today. I hope this presentation can help you about the topic of vector, and I also hope this presentation can be understandable for everyone. So thank you for your attention and participation. Okay, have a great day. Bye bye.